Okay, so this unit we've been talking about the normal distribution. Today we're going to be looking at normal distribution, but the questions are going to be in words. But let me do a quick reminder of last week, okay? So last week we remembered, let me go here in black. We remember our normal distribution. We remember the empirical rule, which you guys have seen it before. Remember, normal distribution, it has a shape of a bell shape. And then we said right here in the center, that's where we have our mean. And we use the Greek letter mu. So we said that's the mean right in the center. And then I can go one standard deviation to the right. So we're going to say our mu plus one standard deviation. Or we can say it here, there's a second standard deviation. So just a reminder, one mu plus two standard deviation, and then one mu plus three standard deviation, or four or five or six or seven standard deviations, as many as we need. Now for mu, I can also go to the left, and we can just say this is one mu minus one standard deviation. This is mu minus two standard deviation. And then I can go mu minus three standard deviation, four standard deviation, five, six, seven, as many standard deviations as I go by. And remember we talked about this last semester. We called it the empirical rule. Remember, if for it to ring a bell, remember that I used the term 68, 95, 97%. Okay, what that meant, as a reminder, is from the mu, if I go one standard deviation to the left and one standard deviation to the right, in between them, so everything in between was 68%. Remember, I call that the 68, 95, 97 rule. Now, obviously, if the whole thing is 68, oops, let me bring this back. Okay, so if the whole thing was 68%, I guess I'll use red. So from the mu to one standard deviation to the right or one standard deviation to the left, the whole thing was 68%. So from mu to one standard deviation, we expected this to be 34%, right? All of this in between. Remember, that was, again, the empirical rule, the empirical method that we learned last semester. Now, what if I don't move in the whole standard deviation? What if, let me just come over it and let's say, what if I had my mu, but I only move up, here's one standard deviation, I only move up to here. I'm just interested in this. I didn't go, if you see, I didn't go the whole standard deviation. I went less than it. Not exactly the half of it. I just went less. So this number, like how many standard deviations did we move? This is what we call the C-score. Remember, this is what we talked about last week, how to find out the C-score. Now that tells me how many standard deviations I move. And then depending on that, I gave you guys a table as well that gives us our percentage, okay? For example, let's say this thing right here, I didn't move the whole one standard deviation. Let's say I move about 0.83. Our C-score goes down to 2 decimal places, so 0.83. And then I look at my table. Let me bring out the table that I mentioned. So here on the right, here on the left, I have up to my first decimal place. My C-score that I'm looking for is 0.83. So here I'm going to look for 0.8. Again, I'm looking up to my first decimal place. So 0.8 is right here. Now here on the top in yellow, I'm going to look for my second decimal place, which is 0.03. So I'm looking at 0.03, which is right here. And then when they meet, it gives me this much right here. So 0.2967. You guys might be wondering, okay, Mr. Leonzo, where are we? I got lost in here, okay? Little recap. Here's my mu. Here's my one standard deviation. I know in between my mu and one standard deviation is about 34%, but I didn't advance the whole standard deviation. I went up to here, which we just figured that it was 0.83. So that this thing right here, again, in between these two blue lines, in between the mu and one standard deviation, the whole thing is 0.34, right? My probability is 0.34. But I'm not looking in between the two blue lines. I'm looking in between my mu and my C-score. I'm just looking at this much. And that I'm going to say it is 0.2967. Remember, this is what we found last week. We talked about that last week. So our C-scored helps us advance to see how many standard deviations did we move, and that's going to give me what's the probability for mu. The probability on the right reflects on the left. Okay, so that was a little recap of last week. Let's take a look at today's work. There's some psychology students at a university completed a dental anxiety scale questionnaire. So far what I've read on the first question is there was a survey done, okay? The scores on the scale range from 0, which is no anxiety, to 20, which is extremely anxiety. Again, so far what I've read is that there was a survey about anxiety. The mean score was 11. Oh, that's something that I need to know. So the mean score was 11, and my standard deviation was 3.5. Assume that the distribution of all scores on a dental anxiety scale is normal. And then I gave you guys right here at the bottom, I repeated the information. The mean score is 11, and my standard deviation is 3.5. Okay, so now suppose you score 16. The mean score was 11, right? Suppose you score 16. Find the Z value for this score. So far, I know my X is 16 because that's the value I'm testing. I know my mu is 11. The average is 11. Average, mean, mu, however you're going to call it. The standard deviation, I use the Greek letter called sigma. So the standard deviation is 3.5. That's what I know so far. Now, for me to find out what's my C value, what's my C score? Remember, C value is basically how many standard deviations did I move? If I move to the right, my C score is positive. If I move to the left, my C score is negative. The way we find this out, I gave you guys a formula last week, and we say the C score, I'm going to go X minus mu, all of this divided by sigma. So in this case, I'm going to go 16 minus 11 divided by 3.5. I'm going to use a calculator. I know 16 minus 11 is 5, and 5 divided by 3.5, according to my calculator, is 1.4285 and 7, and it goes on more. So I'm just going to leave that for right now. But then on the instructions, I'm going to tell you guys how many decimals to round it for. So if I said round it to 1 decimal place, then you make sure your answer has 1 decimal place. If I say 2 decimal places, then 2 decimal places, and then 3 decimal places, and so on and so forth. For this one, let's just say I want to go to 2 decimal places. Well, 2 decimal places, we usually call that hundredth, right? So let me run this to the nearest 100. Remember, TH means decimal. 100 sounds like a 1 with 2 zeros. So that means 2 decimal places. I do take a look at the 3rd decimal place. It's an 8. So the 8 is big enough. So it's going to push my answer to 1.43. Not too bad, right? The C value is not too hard to get. Now find the probability. The next question, reading this along, find the probability that someone scores between 10 and 15 on the dental anxiety scale. Okay, so let me find out. Because there's 2 values, 10 and 15, there's 2 x's. I'm going to call this x1 if you wish, and I'm going to call this x2 if you wish. So there's two x's, there's two values that I'm testing. So I will get two z-scores, two different z-scores. For the first one, I have my x value, is 10, the mu is 11, and my standard deviation is 3.5. And I'm still looking at the same dental anxiety scale. Let me get the z-score for this one. I'm gonna go 10 minus 11 divided by 3.5. According to my calculator, I'm gonna round this to 2 decimal places. I get negative 0.29. Okay. For right now, I just found my z-score, and I found it negative 0.29. Again, let me round it to 2 decimal places. Now with blue, let me do the second x that we're checking. My second x is 15. The mean is still 11, and the standard deviation is still 3.5 because we're doing the same test. So let me find the z-score for this one. I'm gonna go 15 minus 11 divided by 3.5. And my answer, I'm gonna round it to 2 decimal places. So I'm gonna say this is 1.14. Okay, I found my z-scores. Now I do need the z-scores for the probability. Here, I'm asking for probability. Find the probability. Okay, so I'm gonna use the table that I just showed you earlier with the z-scores. That's the one I'm gonna use for probability. Just as a little thing, it's a little recap. I have my figure here. Here's my mu. Let's call this a negative 0.29. And let me call this a positive 1.14. And as a matter of fact, let me break this right here. So I need to figure out how much is this area and how much is this area. And my answer will be those two areas combined. Okay, so I'm thinking, okay, so negative 0.29. I'm looking at this one first. Let me look at my chart. I'm looking at negative 0.29. Okay, I'm gonna ignore the negative sign. So I'm looking at positive 0.29. Like I said, I'm gonna ignore the negative sign because this thing tells me what's the area from mu. It doesn't matter if it goes to the right or to the left. So 0.29. I'm gonna look up to my first decimal place here on the left. So I'm looking on the left, I'm looking at 0.2. And then here on the top, I'm looking for my my second decimal place. So I'm looking at 0.09. So on the left, again, I'm looking at 0.2. That is right here. On the top, I'm looking at 0.09, which is right here. So 0.29 happens to be 0.1141. Remember, we said probability is a decimal between 0 and 1. So 0.1141 sounds about perfect. So let me come back here. And I'm going to say this area is 0.1141. Good. That was not that bad. I need to find this other area. Now for this other area, I'm going to find out 1.14. I'm looking at my z-score, 1.14. So let me come back to my table here. Let me clear this out. Now my z-score that I'm looking for is 1.14. So looking at up to my first decimal place, 1.1, I'm gonna look at here on the side, and then 0.04, because I'm looking at my second decimal place, I'm gonna look at that here on the top. Okay, so at the side, 1.1 is here. 0.04 is right here. So 1.14 is here. You guys see it? So 1.14 is 0.3729. So 3729. Okay, I found how much is each area. Now my answer was, what's the area in between all of it? So I'm going to add these these two areas. And my probability will be 0.4870. That's it. Cool. When I say probability, I expect a decimal number between 0 and 1. So 0.4870 sounds about right. Usually for this type of probability in the normal distribution, we go to 4 decimal places. So that sounds about right. Now find a probability that someone scores above 17 on the dental anxiety scale. Okay, so what do I have here? My x in this case is 17. The mu is 11, and my sigma is 3.5. So let me find my c-score first. I'm gonna go 17 minus 11 over 3.5. 17 minus 11 is 6. 6 divided by 3.5. Round your answer to 2 decimal places. I'm going to call this 1.71. Okay, so my c-score is 1.71. So what I'm interested in, here's my mu, and I'm really looking for 1.71. Let me look at my chart. Let me look at my table. I'm looking for my c-score to be 1.71. So let me go here. Let me clear this out. Again, the c-score I'm working with is 1.71. So here at the side, I'm going to look for 1.7. Here on the top, I'm going to look for 0.01. 1.7 is right here. On the top, 0.01 is right here. So they meet at 0.4564. So I know this area is 0.4564. Let me read the question. It says, find the probability that someone scores above. So I'm not really interested in just that area. Let me highlight in blue. I'm interested in this area. I'm like, okay. So one thing I can see is from the mu to the left. So all of this area on the left is 0.5. Again, I'm interested in this area. I know the whole probability is 1. So the whole area under my graph is 1. But I have to take away this. So I have 1. My whole probability is 1 minus 0.5 because I don't want that. And then I also have to take this. So minus 0.4564. So I'm going to use my calculator. And it gives me, I'm going to round this to right now for 4 decimal places. It gives me that this area that I'm looking for is 0.0436. And that's it. Gotta pay attention to what thing I'm asking. Keyword here was above. So that's why I said I'm looking for the information on the right. Okay, that was not that bad. Let's take a look at another question here. The study of green sea turtles discovered that the curved shell length of this curve is approximately normal distributed. Normally distributed. Okay, so we're looking at normal distribution with the mean of 53.6 centimeters and the standard deviation is 11.3. Okay, let me write some information that it's important here. I found out that the mean is 53.6 and my standard deviation is 11.3. We're dealing with centimeters. I'm just going to write the numbers, but we know we're dealing with centimeters. The minimum and maximum size limits for captured turtles in the legal marine turtle fishery are 39 centimeters and 59 centimeters, respectively. So 39 is the smallest that I can catch, and 59 is the biggest that I can catch in order for this to be legal. Okay. How likely are you to capture a green sea turtle that is considered illegal? All right, first of all, let me find out what's the probability that I do catch a legal sea turtle. So I'm gonna call this thing, my minimum is gonna be my X1, and then the maximum is gonna be my X2. I'm checking two values here. And I saw that this was normally distributed. So I'm gonna do this right here. Here's my mu, and I have to find two, keep in mind, two C-scores. For my first one, I'm looking at the minimum value. More likely my C-score is gonna be negative because I'm going to the left of my average. My first one, my X is 39. The mu is 53.6 and the sigma it's 11.3. So when I do this to find my C-scored, I'm gonna go 39 minus 53.6 divided by 11.3. My answer, I'm gonna round it to 2 decimal places. C-scores, we always simplify to 2 decimal places. So my C-score in this case will be a negative 1.29. So negative 1.29. Okay, so it seems like there's one area that I'll be looking for. For us to see that I'm doing a separate question, let me change my writing to blue now. Now I'm looking for the maximum. So my X2 is 59. The average is still 53.6, and my standard deviation is 11.3. So the way I'm gonna find my C-score, I'm gonna go X minus mu, and all of this divided by sigma. I'm gonna use a calculator, and this thing gives me 0.48. Keep in mind I rounded to 2 decimal places. Okay, so it's about here, 0.48. That gives me this area. Okay, so let me take a look on my table. Let me look for my negative value first. Negative 1.29. When I'm looking at this table here, I ignore the negative sign. So I'm really looking at 1.29. The negative sign is for me to know that it was to the left of my mean. That was the negative sign. But when I look at here, my table, I just look for 1.29. I know here on the left, I'm gonna look for 1.2 because it's up to my first decimal place. And here on the top, I'm gonna look for 0.09. So 1.2 is here. 0.09 is here. So that probability is 0.4015. Okay. So 0.4015. Let's write that thing down. 0.4015. That's this area. As a matter of fact, let me write it in red, I guess. So we know I was looking at the red area. 0.4015. Okay. Now I need to find the other area. My C-score, as we can see in blue, my C-score is 0.48. Okay, so let me come back to my table. And then in here, let's change this to blue. I'm looking for 0.48. So here on the side, I'm gonna look for 0.4. And here on the top, I'm gonna look for 0.08. So 0.4 is right here. 0.08 is right here. So 0.48, I'm gonna say it is 0.1844. So let me change this to red. I mean blue. 0.1844, right? I guess let me leave the center black. Okay, so I have two C-scores. I found the percentage of each. Again, the negative sign, it just means it's to the left of my mu. Positive sign, it just means it's to the right. I'm gonna add my two areas. So 0.4015 plus 0.1844. And I'm gonna say my legal area, let me just emphasize here, the probability that I get a legal fish is 0.5859. Let me read the question here. How likely, let me highlight my question here. How likely are you to capture a green sea turtle that is considered illegal? Okay. My table gave me what my percentage of legal fish is out there. So for me to consider what's illegal, it's the remainder, right? If 0.5859 is legal, for me to find out how many illegal fishes are out there, I'm gonna do 1 minus the legal, so 0.5859, according to my calculator, is 0.4141. Beautiful. Now that I have this question, let's change questions a little. Let me add a extra sample because you guys are gonna have this on your notes, on your homework. What if I wanted you guys to get only 3%, are illegal fishes? So what's the biggest size that I can do to make sure that you guys get 97% of the fishes? Yeah, let's say I have a problem where there's too many fishes on the sea and I need to get rid of some of them, but I don't want fishermen to come and capture them all. So I'm gonna say, okay, I know the average of the fishes are 53.6. I know the standard deviation is 11.3. I want the fishermen to catch a lot of fishes because I have too many. So I want them to minimize the population, but I don't want them to be able to get them all. So I want to keep at least 3% of my fishes. So one fisherman to be able to catch 97% of the fishes. What's the biggest size that I can choose? Okay. One thing for that, let me come over and let me look for my table here. Remember I said I want fishermen to be able to catch 97% of the fishes. Not 97% as a decimal. How does that look like? It looks like 0.9700. Okay, so I want fishermen to be able to catch less than that. I look at my percentages. Where is that? 0.9700. The biggest it goes to, it's way less than that. Yeah, Mr. Leonzo, because this is only telling me half of my fishes. Okay, so let me take half of it out. So let me take away half. So let me take away 0.5. So I'm looking for 0.4700. Okay. Now that number will be here, 0.4700. It's in between here. All right, so if I choose 1.88 for my C-score to be 1.88, you guys see where I get the 1.8, and then you guys see where I get my last decimal number. If I choose 1.88, it's a little bit too small. It's a little less than what I want. But if I choose 1.89, it's a little more than what I want. In order for me to not go over 97%, I'm going to choose this value. I don't want to go more than 97%. So 96.99% sounds about right. So my C-score is 1.88. Okay. Let me come back here. Let's open up some room here on the side. Let me see. I'm erasing this real quick. So I said I wanted 97%, right? Because I wanted legally to be 97%, so illegal 3% of the fishes. And then we found out a C-score. According to my percentage, my C-score, we found out that it was 1.88. Okay. Now, what's the biggest size fish that I can choose? I never said anything about the smallest size of fishes that I can choose. I just said, what's the biggest? Okay. So what I'm going to do, I'm going to go my mean plus 1.88 standard deviations. And that's the biggest size of the fish that I want. According to my C-score, according to my percentage, I got my C-score. So according to that, I'm going to go my mu, my average. We said it was 53.6 plus 1.88 times 11.3. 11.3 is my standard deviation. I'm going to use a calculator. According to my calculator, I get 74.844. If I'm asked to round it to 3 decimal places, there you go. If I'm asked to round it to 2 decimal places, we know how to round up. So the instructions look at how much to round it up to. Okay, that's not that bad. It was easy to find. Cool. Let's take a look at this last question. Consider there's a country where to become a president, a candidate must win 265 of the total of 528 votes in the electoral college. Okay. This is something that we see in our government class. So that's nice. Let's suppose that the largest region gets 59 votes. Assuming that a candidate wins this region, the number of additional electoral college votes can be approximated by a normal distribution with the mu to be 238.5 and our sigma to be 45.9 votes. Given that the candidate wins the largest region, what are the chances that he or she becomes the next president? Okay, So they need to win 265 votes, right? There's a total of 528, but they need to win 265. Remember, it says there's a region, things here is it assuming that a candidate wins this region, the 59 votes. So those are given. So I'm gonna say my X value, what I'm gonna be checking is out of the 265 votes, let's say I already won, or this candidate won the 59 votes already. So how many more votes do they need? Well, they need 206. Good. The value that I'm going to be checking with, my X value here is going to be 206, not 265, because they already won the 59 votes from the biggest state. So my X is 206. My average, or the average of the votes, is 238.5. And the standard deviation is 45.9. Okay, what's the probability that this president wins? So I'm just going to look for my C-score first. My C-score, I'm going to go 206 minus 238.5, divide this by 45.9. So 206 minus 238.5, all of this divided by 45.9. I'm going to round my C-score to 2 decimal places. I get that my C-score is negative 0.71. Okay, let's take a look. So it's negative 0.71. I need to look at my chart. Let me clear this all out. Okay, my C-score that I'm looking for is negative 0.71. Remember, when I look at here, I don't look at the sign. I'm just look at the number 0.71. So here's 0.7, here's the 0.01. So it is 0.2611. Okay. 0.2611. What does this tell me? Okay, let's see. From my mu to my C-score, negative 0.71. This area right here is 0. What did we say? 2611? Let me double check. Yeah, 0.2611. Okay. Now there's a few areas here. From the mu all the way to the right, this is 0.5. This other space right here at the very, very end, I'm gonna say it is 0.2389. How did I get that? Okay, well, I just went, the whole area is 1 minus 0.5 minus 0.2611 and gave me that area. Now, this thing, let me highlight it in green. This area is the area that will make my candidate lose, right? If I get less than 206 points or less than 206 votes, my candidate loses, right? This area in yellow is the area that my candidate, what's the probability that my candidate gets between X and mu? So what's the area that my candidate gets in between 206 votes or 238.5 votes, right? That's the area, that's that area. Now let me highlight in light blue. This is the probability that my candidate gets more than 238.4 votes. So which area or areas will make my candidate win? You guys will say, well, this area, because I get more than 206 votes, but less than 238.5. Remember, my candidate needs at least 206 votes. Okay, so that area wins. How about this other area? My candidate gets more than the average votes. I only need 206. Okay, so let me add those two areas, and I'm going to say the probability that this candidate wins is going to be 0.7611. Cool. Not too bad, right? Let me zoom out so you guys can see exactly what we did. Any questions, you guys can always find me.